or should we get going?
I think so.
All right. Why do you want to take the reins? Be in charge, sir.
Hello and welcome to the, I don't even know what date it is, Wednesday, December 12th, special edition of the Cluster Lifecycle. Specifically, having a discussion around how can we do HA enablement for the cluster API. So we have quite a few people in the room here today at the FDO office, and we have a few people that have joined over video as well. So, come on in. Basically, up until now, we've talked at a super high level about how do we do HA with Cluster API, and I think now we've finally gotten to the point where we can start hashing out actual ideas. A lot of the groundwork that we've already done, it's been wrapped up, and now, at least for the AWS provider, we're starting to look at implementing HA, and the current way that we would have to do it would be to basically build a new custom workflow outside of the cluster that replicates a lot of the cluster cuddle workflow, but then just continues to add HA control plane machines, which is very error prone, very kind of tedious. So we wanted to start up the discussion about how do we sit there, like we discussed in the past, start making that control plane part of the actual cluster object itself instead of having to be orchestrated externally. I know when we've discussed it in the past, there have been a few different ideas and concepts of how this can work. One of those is, I don't see Hardik here. Okay, Mark.
I can talk.
Okay, great. One of those is the model that Gartner has chosen, and then others have talked about potentially continuing to spin up machines, but have the control plane machines actually be managed by the cluster object itself. Now, I don't expect that we will all fully agree at the end of today on one single path forward, but I'm hoping we can get through enough of hashing out these designs to at least be able to walk away from here and start putting together some concrete proposals, and then we can kind of continue to iterate from there. So to start, would you like to go into kind of the Gartner model and kind of?
Yeah, so we currently simply host our control planes on top of Kubernetes. So this is one benefit out of the box, and we don't currently support even HA. Even if it goes down, it goes down for like negligible amount of time, and by the time it's back up, it might be some downtime, but it's like a network hiccup, and in most cases it's not even noticeable by end users.
So for the shoot and see clusters, they're non-HA control planes.
We currently don't have. We can scale for example, the API server horizontally, but it's not that big of a problem. Even if it crashes, Kubernetes is really fast, so it's.
And you're also running single SIG.
Yeah.
So the HA is handled by the Kubernetes cluster, the components.
It's not HA, but in a more stable way that a normal virtual machine, which if the virtual machine crashes or there's corrupt memory or so and so, right. It's much better to run the workload on Kubernetes than on bare metal or virtual machines.
Stepping back, I don't know how many people went to Megan's talk yesterday. That was yesterday. But it might be worth talking about what we mean by HA, because I think what you're getting at is basically multi-master, which is different than, not necessarily the same as highly available, right? I think if we want to explicitly build multi-master, that's fine. If we want to try and say it's going to be HA, we should figure out what we mean by HA and make sure we're actually meeting those goals. Because I think what Gartner does, like they would probably call highly available for some definition of highly, but it's not multi-master, right? It's not rough. even if you're running like 2 control managers, there's some like least timeout before the next one takes over, which might be just as long as Kubernetes rescheduling the pod and starting it.
Yeah, I mean, even if you have, even if you're smart and you run your control manager on Kubernetes, you can actually just directly talk to the and you know that your control manager is down. You can more or less, in most cases, directly talk to the API server and then remove like this config map, which is more or less used for the locking, and then you can boot your control manager faster. So, and it's.
So I guess my point was, I think it's okay if we want to talk about Multimaster, but we should say it's Multimaster and not HA.
Yeah.
Try not to conflate the two.
Yeah, and that actually brings up a point for the machine-backed control plane that I can't remember if it was Daniel or David that I was talking to the other day, where we could provide basically, at least on like the AWS side or some of the other cloud providers, have the concept of, a persistent machine that will, recover from failure and come, recreate itself and come back.
There is a video camera, so you probably don't want to sit ahead of it. So it's kind of slide it around.
Other people are coming.
Yeah. If we need some more chairs, I can.
Yeah, we should probably need.
Chairs. I'll be back in a moment. I'm not above sitting on the floor. So.
Also, the Wi-Fi password for people that just got here is FTO guest, and the password is on the whiteboard. And then I think Nadir started adding notes to our regular sort of meeting doc for the cluster API breakout. So if people that want to help take notes, pull that doc.
So I think it's important the distinction that you make between different definitions of HA. I know at Samsung we're looking at doing managed control planes, and having single node fast recovery may be beneficial for a large number of our users because they create clusters with 2 to 5 nodes in them, in which case it doesn't really make a lot of sense to run a 3 to 5 node control plane. By the way, the reason I say 5 is that's what's required in order to tolerate failure during upgrade. So it seems excessive, but that's why we say 5. Justice Anna Robert recently pointed out to me that if you are concerned about failure during an upgrade, maybe you should scale up before the upgrade and scale down so you don't run 5 all the time unnecessarily. I think that's a good point. But I digress. So that
So you're
distinction.
talking about for SIG specifically, right? You don't necessarily need 5 of every component to be safe during an upgrade.
Just that.
Just SIG. That's, I guess maybe that's another point, is to distinguish between like the full control plane stack versus specific pieces that need replication. Because they all, like Megan pointed out in her talk yesterday, each of the sort of layers of the stack has a different sort of way it might be replicated or what happens if you're replicated, right? And for SID, yeah, 5 is what you need to drop one, but also get a little right.
Do we want to take a step back and provide a little bit more context for that? I know it might be asking a lot to give a summary of the talk, but
yeah, I mean, the main point is, HA is just having a high SLO. So you can achieve that in many ways, but you need to look through your entire system and make sure that every component can handle failures and that you know how they're going to handle those failures. So even if you have a single replication of the control plane, as long as you know how fast you can recover from failures, I would still consider it HA, even if it's not multi-master.
So one of the things that, that is a challenge for me is, standing up, multiple control plane instances, generally adds a lot more overhead and management than is generally required in most situations. The downside is that a lot of people that are coming to Kubernetes new and are looking to adopt it, it's sort of a checkbox that they're looking to adopt, So it's almost a challenge of, do we lose adoption, by providing HA capability without, also providing multiple control plane.
I agree that there's an optics side to this. I wanted to ask a question specifically about something that Robbie said. talked about the time it takes for release to expire so that you can start an API server, for instance. I was curious, as more and more applications adopt the operator model, does the resiliency of the API control plane in general become more important? And do we need to have shorter and shorter? I mean, is it possible we reach a point where even being out for 5 minutes is noticed by an application user? In which case, the single node master becomes untenable.
I think this affects quicker on PMS than almost in any of those.
Sure. So you're asking a couple of different questions there. So back to Jason's point, when GKE first launched, a lot of people asked whether we had an HA control plane, right? Because control plane is hidden from users; they can't actually see how it's implemented. And Brennan always liked to come back and say, well, what is HA? Like we offer an SLA, it's 2.5 nines or whatever, I can't remember what the number is, but whatever the number was at the time. And like, why should you care? Right? Why do you care whether or not it's replicated? Because they're really asking about replication, they're not actually asking about availability. And I think that was something we tried to spend some time educating users on. Some users actually have requirements, not necessarily for availability, but for resiliency in terms of failure domains, right? So that's where, like Meg was talking about regional clusters yesterday. Regional clusters are replicated across failure domains. And for a lot of customers, that's actually more important than the availability number, right? And so a lot of people want the replication so that a zone can go down and things keep working, not because they need to be able to make requests and not have a 5-minute blackout, right? So that's a sort of another reason to do multi-master. In the Gardener case, you might be able to get that by just rescheduling quickly in case the zone goes down and still just have a single one, right? So for GK, we implement it with multi-master, but that's not necessary.
But one case with a single, if you go with a single master, even though you can bring it out, I mean, is it single instance of HCD? I mean, I think that data and caring about whether we have any cases where in the single instance goes down and then you get into a, let's say, a situation where you can't bring back the HCD or something on that effect, then that is that's a case where it might be difficult, even that you can schedule a pod, manually start it for that matter, but you might not be able to recover your entire control plane. So that's probably one case that I can see why you probably might want to have at least 3 replicas of HCD. Even though you can probably get it away with just one API server, but you probably, from the HCD perspective, I think you probably need at least a multiple copy of that data just to be safe.
Yeah.
I mean, but you have backup. Nobody has backups for this kinds of situations because HCD can often, not often, but in some edge cases, grouped and cannot simply start physically.
No, so that actually leads to my second question that I was going to ask you is like, when you guys are running just a single instance, are you guys automatically doing is there like some cron job that's or Kubernetes?
We have a sidecar.
With the sidecar, we do full snapshots all the time. So every 20 hours, whatever is configured, and then incremental snapshots because we, of course, may not lose any state.
Okay.
If the HCD state doesn't fit anymore the reality, we are of course in deep trouble. So therefore we have continuous backups, continuous incremental backups that we are running.
Yeah, so it comes down to your durability SLO, right? Like if you lose HCD, how much time are you okay losing, and then you can sort of configure your continuous backups to have a recent enough snapshot that you can recover across zones. And there are other ways to do that too, right? You can run multiple copies of HCD. Someone told me yesterday that the HCD folks are working on adding support for non-voting members, which would actually be a really slick way to do this. Because you could still have a single HCD, but you could put a non-voting member in a different zone, which would effectively do real-time copying of the data out for you. And then if you've lost the first zone, you can turn that one into the one voting member, but it's got sort of a snapshot. So I think going forward, we'll have multiple techniques we can apply to giving you that durability SLO for your HCD data.
I've worked with a couple of customers on implementing some cluster API stuff right now. As a field engineer, I have to have plenty of stuff equally, by the way, to get you all. And one of the concerns that they had immediately around kind of having that argument about whether we should just do a single quick recovery master since we have an API to do that might be better, or whether we should do like multi-move, really came down to like, well, the conversation around like, well, how do we actually manage the C cluster itself, right? Like with the C cluster, you would feel like you would need to have multi-node to be able to, because it is such a high importance target, right? Like, I think that's what I wanted to bring up.
Yeah, I think for that's the Gartner terminology of C cluster.
Yeah.
I think other people are calling it management cluster.
Yeah.
Just in case people don't understand what C means.
So this comes down to the point where I feel like we're going to end up having to solve both. But I do think that there's absolutely going to be a group of people who are going to see that value in a single, very quick recovery master. And in fact, in this particular instance, I can't tell what company I'm working with right now, but like they're fine with doing the single master for the child clusters, but they're not okay with that on the management cluster. That's untenable.
Customer runs the management clusters as what was your terminology? So master manager.
I was saying C cluster was getting to the primary.
Yeah. Okay. So basically, you're running the C clusters, also the shoot clusters.
Yeah.
They are also automatically managed by God, and therefore we are fine. Yeah. So same mechanisms apply for the shoot clusters.
But the availability and resiliency that you need in the management cluster is going to be higher. Like the SLO you have for like a child cluster and the API, I feel like it's going to be a different SLO than for the thing that governs all those clusters.
You ask our users, I completely agree. And that's fine. They want the same SLOs, and you can basically, in case of a disaster, migrate that control plane.
So, and I think there's a big differentiation depending on how large of clusters you're managing with this, and also what types of workloads you're managing on it. You know, if you're managing, you know, workloads that can be spread out across multiple clusters and things like that, you know, there's much less of a concern there than if you're running, you know, larger workloads that are accessing a lot of persistent data as well. And then that's where, you know, having, you know, that additional multi-control plane, you know, availability on the child cluster or, you know, whatever cluster makes a lot of sense there. You know, compared to somebody who's running more, you know, maybe like stateless workloads or doing some other type of management to make it easy to, you know, that if there is a problem with the cluster, you can migrate other ways.
I mean, the shoot cluster can span multiple availability zones. So can also the C cluster. That means also your control plane can. So if one availability zone goes down, of course you can get the same to be back. But we have the backup, we can easily migrate. Yeah. So that's kind of the idea. And therefore, that was actually a great breakthrough for us to use the shoot clusters also for the C clusters. So we don't have to use a different technology for managing.
I'm a fan of that.
Yeah. And also what you said yesterday, we had a discussion with Alexander Moore. So it was also our argument, but he seemed to argue with the customers of GKE that basically say they want to tick this box on Multimaster. And that's something that at present at least we cannot provide.
Yeah,
so
that comes back to like customers are asking for it in some ways out of naivety. Like they don't know that they don't necessarily need it. Some customers, what they want is multiple failure domains.
Yeah.
And in their mind, multiple failure domains means multi-master, right? Yeah. Because they don't understand that there are other ways to achieve resiliency across failures, right? And so there's, you know, we go back and forth with our product managers of you know, how much do we try to educate users versus just give them the checkbox they continue to ask for after a couple of years of us trying to educate users.
Yeah.
I think one reason for that might be if you go to the Kubernetes website and say, okay, how do you deploy a highly available cluster? That's what exactly it points to, to deploy multi-master. So that's essentially where the source is coming from.
I mean, in most cases, most users only care about their workload. I mean, if their API server goes down for like 1 or 2 minutes, it's okay. But if the application or what they're actually paying for, I mean, their profit, it's yeah.
Yeah, I think that's historically been true. But what David said earlier about more people building operators, more people sort of using the Kubernetes API as sort of a storage system and a database, that's becoming less true. People do care more about availability of the API server itself. Sorry.
Yeah, exactly. This is what I also want to say. So I think the question is like, if it's clear for everyone who building operator that the master can go down for a certain time, and how is the operator then interacting if it's immediately going crazy, or if it knows, okay, I must handle the situations. And I think this should be also somehow addressed at the guys to building operators, that they must have this in mind, that it's not like a given case that the master is highly available and you can assume the API is every time there and it's working. So you should have this in mind when you're building an operator, that it can go down.
Another pattern to consider, we spend a lot of our time talking about this in the field, helping people come to deploy Kubernetes in a resilient way. and that is that we will push for the idea that etcd needs to be on its own nodes and managed in some way more controls on those other nodes rather than stacked masters to have etcd and control plane nodes together. I could see that being valuable to cluster API in the future. Obviously, I don't think it's a short-term goal, but I think it is an interesting thing. I'm curious, like, what other thoughts.
Is that mostly like on-prem folks that you're telling to separate? I think most of the like open source deployer tools that I see still do sort of the stacked model, right? Like Kubernetes by default does a stacked model, Kops does the stacked model. I think Kubespray also does.
They do these things by default, but in almost every one of those cases, they can be, except for CAPS, of course, can be told to just point to an existing.
Exactly.
And that opens up some interesting opportunities as well, because right now we have to special handle the control plane instances, having etcd also co-located. Whereas if we separated etcd, then that gives us the ability to kind of treat those control plane instances much more like we currently expect to treat the worker nodes, to where, you know, a rolling upgrade could be just tear down, you know, the control plane and bring back a new control plane instance.
Yeah. Martin, do you guys for Gartner, I mean, obviously they're running as deployments.
Yeah, I mean, yeah.
Do you
So
pin them to the same nodes, or do you?
Yeah, so currently we don't use like pot affinity, anti-affinity, and so on. So I mean, we should, but yeah, we currently we probably should, but we currently don't.
Okay, so the different components kind of just float around,
everywhere.
and they aren't forced to be sort of affiliated.
It's Kubernetes, so yeah.
Yeah, I was just kind of curious if you found it necessary or useful.
I mean, there's always the when you run containers, there's always the lazy neighbor problem with like networking and so on. So, but yeah, if you're really keen on, then you can use like the Kubernetes native primitives, like.
Especially around IO as well.
Yeah.
Like,
Yeah.
etcd is so IO sensitive. The win of turning control planes or control plane nodes into something you can just rip and replace, that is a huge benefit. And when you don't bring that complexity of etcd into the control plane as well, that helps a lot.
Yeah, it makes them basically stateless. Because you can move your state on.
There is one downside though, in that we then now have to manage etcd. And you know, one of the advantages of managing etcd as part of kubeadm is that we also keep the version of etcd in lockstep with the version that has been tested and approved for release of Kubernetes. So we would have to have some way to, you know, surface that data up and actually handle that as part of managing it.
You can use kubeadm to bootstrap only etcd though, right?
Exactly.
So
Yes.
I think I give you your version lockstep that you're looking for. That's actually what we do. We run etcd on separate nodes and just use kubeadm to bootstrap. We provide just a kubeadm config that bootstraps etcd, and then let it be our inventory system to share with the control plane.
I remember, you know, maybe a couple months ago, asking this question, you know, whether so if we wanted to run etcd separately, you know, now or in the future, we would have to represent that somehow in the API, whether it's, you know, a role, that's, you know, etcd role as opposed to a master or workman. I remember getting some pushback to the idea, or to even the idea that etcd falls in the scope of cluster API. But maybe we come around.
Well, so part of that is the elimination of the roles from the high level machine objects as well.
Yeah, I think that's my goal.
Well, no, I mean, it makes sense, because when you start looking at how different users and how different providers can implement things, you know, you can have multiple permutations of kind of roles. You can even have kind of different sub roles of, you know, worker nodes and things like that, and trying to hard code and bubble those up into the common objects just.
Right, and it doesn't align well with things like what Gartner's doing, where basically everything is effectively just a worker node, and then use Kubernetes to schedule things on top of it. Is a really cool use case. And then you get these like combinatorics of, is it a master and an etcd? Like if I say it's a master, what does that really mean? Do I have to enumerate every single component that runs on it? At that point, like I'm effectively becoming a scheduler, which seems like a bad thing for the API. So there are a lot of reasons to get rid of role, but it does leave us in this place where we don't have a way to sort of easily say, this is an etcd node, this is a control plane with or without etcd, this is a regular working node that's consistent.
If I may ask a direct question, I mean, the reason why we went for Kubernetes was basically a assuming, okay, this is a general problem. So whatever application gets scaled in Kubernetes has that. And so we thought, okay, we go to Kubernetes. If it can't manage today, then it will manage in a year from now. And so discussing this special use case of etcd in that context is a heretic question. So why are we doing that? If you believe Kubernetes is the right underlay, deployment underlay, we hope it will develop to a point where we can actually scale it with no problem and can influence things like or solve the problem like noisy neighbor. This is the ultimate goal.
This is analogous to the same conversation that we have over and over again with Kubernetes, in which we describe the fact that hosting stateful services comes at a bit of a higher cost than hosting non-stateful services, right? This is the ultimate stateful service.
Ultimately, we want to do that, right?
Yeah.
So,
When I've also heard some rumblings around KubeCon about there potentially being people looking at abstract, fully finishing the abstraction of the data store for Kubernetes and potentially being able to leverage, cloud provider,
I think Microsoft announced something yesterday where you can use Cosmo DB. It's Cosmo DB as the backend for.
Basically wrote an SIG gRPC API.
No, they replaced the data store. So etcd has like a shim, and they can change the backend.
Yeah. Okay. So they still run part of the etcd code base and not the part of the rest of the database.
Yeah.
But in effect, then that takes the state away and makes that shim stateless, right?
Yeah.
Unfortunately, right now, the common use case doesn't afford us that ability right now. So, I think the idea of hosting etcd on Kubernetes is great, but at some point you have to have a cluster to get going, and that bootstrapping, process, and not everybody, if you have the cluster manager cluster, if you're looking at potentially hosting, you could potentially use that to host it. But if you're looking at multi-provider or multi-region or any type of management like that, you're then separating your control plane, across a large geographical region from your worker nodes.
Essentially, I think Gartner sort of does this and maybe solve that problem.
Yeah, so we more or less have, like for AWS on Europe, we have one cluster, for example, in Europe East, and then or Europe West, and then for every different provider, we have like cardinality, provider and then the zone. So you can do this thing.
So you would have like a different, seed cluster?
Yeah. So on one axis you have the providers, and on the other axis you have the regions or zones.
Sorry to interject, guys. Can somebody who is in the room, it's fairly hard for us who are remote to hear, keep up with the notes, because those of us who are trying from remote are not able to keep up. Please, thank you.
Yeah, okay, can you hear me better?
Yeah, we can hear a little bit better. It's just the quality of the signal with everybody talking. And we can't keep up with the note taking. So if those who are in the room could please chip in on taking the notes, that would be fantastic.
Okay, great. So basically we have an X and Y axis, and in the one axis we have the providers, and in the other axis we have the zones, and that's it. So we have.
What is more about the bootstrapping? So
yeah.
It's only about the bootstrapping that it can basically survive without having another provider setting up this root cluster. Is that the question?
Would it be helpful for, is everybody familiar kind of with the Gartner model right now? Would it be helpful to kind of give an overview?
I'm guessing somebody in the room isn't, so it's probably,
No, yeah, better. Yeah, I can explain, but he can explain better.
You can use the export.
Oh no. I mean, you have stock is better.
Okay. Then good. I will try my best to. Okay, so basically, we started off with manually created clusters, Kubernetes clusters, and then from there on, we have written
it's now an API server extension, the Gardener, and has an API server controller manager. It basically listens for custom resources, the cluster definition. So we have our own spec, how we describe, okay, this should use a cloud provider, AWS, GCP, whatnot. Networking, DNS, all these things. The controller manager basically then knows of the seed clusters. It has created them. So basically Gardener has created all the seed clusters automatically. And then the scheduling part basically decides, wait a minute, you want a cluster to be run on GCP in the region, blah, then it looks for the seed clusters that are there. Maybe there are multiple ones, then it picks one with the most capacity and then schedules the control plane. Actually, more things happening underneath. Basically, it first starts to create all the networking, set that all up. It is creating, it is putting the control plane onto the seed cluster. It's waiting for it to come up. It is provisioning the nodes by the help of a machine controller manager that Hardik mostly developed, and it was also the part of your work on Sheet API. And waits for, again, these components to be ready for the nodes to book in, then it deploys the rest on the kube system, and then you have your cluster. Now, the Achilles heel of all of that were in the beginning the seed cluster, so somebody had to set them up manually. We have a separate project. So in the beginning, it was relatively easy. We used COPS for AWS only, but of course that didn't scale because we needed also OpenStack. So we have written our own Terraform setup, and we had always this double maintenance. Of course, we didn't want to have that. And at one point in time, we decided, okay, Gardener runs so reliable that we said, okay, the seed clusters, why not create them same way? So basically a shoot clusters, and that's the current state. And the Achilles heel is still this root cluster. And for that, we basically have done multiple POCs, and we know how to do that. We need now to codify it. Don't know if we should talk about that one. Basically, we had a longer exchange, Robert, and we about the whole setup. But in the end, so we have set that up multiple times by hand. It's basically a ring of shoot clusters. You bootstrap with whatever cluster you have. Can be a Minikube, doesn't matter. You deploy there a Gardener, you create 3 more clusters. Then you migrate the control plane so that basically one cluster has the control plane of the other in a ring. You place Gardener on top of it. So it's easily set. It's harder done. But when you have it there, basically if a cluster fails, doesn't matter. There are still 2 clusters there. That means the etcd that is there is an etcd cluster that runs on all these 3 clusters. These clusters can be in different infrastructure. It doesn't matter. It's a latency issue, of course, in the end. But Gardener isn't doing much. Gardener is basically pushing most of its work into the seed clusters. So Gardener itself is basically only the watchdog that basically pushes information into the seed clusters. The stuff happens there. It reconciles information back so that it knows, okay, this is the status of the whole thing. This is what I've created. And yeah, so this ring therefore works if one part gets cut off. Everything will be eventually then by Gardener reconstructed. I mean, there are multiple layers in between. Usually Gardener is not even needed. Since we schedule on Kubernetes, that's the nice thing actually. For most problems, Kubernetes takes already care. And only if something really breaks networking, somebody destroys something. So we have seen that, people fiddling around with security groups or whatnot. In the next reconciliation phase of Gardener, it will be repaired again. And that's what we actually want. We do not want to use different tools and different Kubernetes services to get to this root cluster. We have done that already for the seed clusters. These are shoot clusters. We want to do that for the root cluster as well. That's basically the idea. I would have also slides, but this is not, I'm a bit surprised. I mean, we are not trying to sell here Gardener. It seems it was a topic, but we are very much interested in the cluster API specification. It's an open source project. We want adoption. We want basically to have these clusters running everywhere. That's our interest.
As a user of Gardener, I can speak to this problem a little bit. So the very root cluster is called the Garden cluster, and that could be a local cluster, Minikube. And then it uses Gardener itself to spin up a shoot cluster in every availability zone to every cloud provider that you're interested in. So then you run the control plane components there. So you kind of only have to solve that problem once as an organization.
Yeah. So with that,
does it introspect that and automatically do that, or is that something that you can limit and configure?
Introspect what?
So when you set up the, how does it, are you predefining which, cloud providers in which availability zones and regions you want to?
With CRDs, yeah.
Okay.
So these are their cloud profile CRDs, and there you can describe which infrastructure. So basically only the infrastructures that are right now in source tree supported can be configured. So AWS, GCP, Azure, and OpenStack. Alibaba is coming soon. Packet has started adopting it. VMware is in discussion. So I'm not sure if anybody is here from these teams. So and then you basically create the in the cloud profile you specify the machine types, the regions you want to have, the zones you want to have. So you're expressing it there. And then in the configuration of Garden itself, you say, so this is only the configuration what shall be supported, also advertised in the dashboard, and you can narrow it even more down with the concrete configuration. But basically, this is it. The cloud profiles are CRDs. So we very much like to use everything we can get from Kubernetes. Every single bit, we don't want to develop that stuff. So yeah, that was the design principle all the time. Use what's there. Therefore, I had this heretic question, because we know there are certain limitations, but it was our strategy to say we don't want to solve these problems differently. I think Kubernetes will develop, and that's the reason why we completely bet on Kubernetes. Everything runs there, so we do not use another technology. Before that, we have 2 years of experience also with Cloud Foundry managed by Bosch, and that was always a pain to basically use one tool. I mean, Bosch is a very good tool, don't get me wrong, but still using one tool to manage some completely other technology. And with Kubernetes, we wanted to get rid of this split. So we are now also knowing very much what we provision to our users, and that feels good. So eat your own dog food on that level is really perfect.
So the biggest question for me then is, if you have, the two models aren't very
dissimilar, and really, it's just a matter of where the control plane is hosted, and how many
kind of Kubernetes clusters
are involved, to completely reconcile, these objects. In the Gartner model, you have the root cluster, which is feeding down to the chute cluster, and the information's feeding through there before you actually start provisioning, the cluster resources, versus the current model of the cluster API, where, you just have the one kind of manager cluster. I don't know if,
So I guess one question I have along those same lines is, like for other folks, they're using the management cluster sort of deployment techniques. I think you guys said you were exploring that. I know that Samsung's exploring that. VMware's exploring that. How are the control planes being run? So I think Bert has explained that for Gartner, the control planes are run using Kubernetes resources in what we would call the management cluster. Are you guys, when you use the management cluster to create a child cluster, are we still running Kubernetes in it using static pods, or are we actually trying to use Kubernetes to manage the resources directly and not using static pods?
Yeah, for the way that we've been doing it so far,
we've been standing up an actual machine instance, and the standard cluster cuddle workflow, machine instance and
kubeadm init to initialize the control plane.
The one benefit that we've seen so far to that is the bootstrapping process
seems to give you a way to get that control plane
without having an existing control plane. So you're using
the same process to bootstrap the initial cluster,
even
the bootstrap cluster versus a follow-on cluster.
Right, so again, going for consistency and tooling, right?
Right.
From a slightly different perspective,
yeah.
So you're saying, like, I want to do the same thing here and here, and not to manage in 2 different ways, which is exactly the same argument, but
yeah,
they're using a slightly different implementation. Do you know if you guys want to chime in about, like, are you guys using sort of the same thing that Jason's been describing?
Yes. I actually had a question about the reason for the root cluster, and why you need to distinguish the root from the chutes.
We don't really need to distinguish it, but we need a place to deploy Gardener to So the only purpose of that cluster is to host Gardener. In the Gardener ring, we basically have kind of a nodeless cluster. We have multiple, so if you imagine you have this ring, and then they are basically running etcds on all of the free clusters, API servers. There are no nodes. That's kind of a virtual nodeless cluster. We need it only basically because Gardener is an API server extension. That's all. So we need this place. And how we come to it and where we run it, we don't care, but we prefer, and therefore we have the ring, to of course use our own clusters. Because then we can also spread them even across infrastructures. As said, Gardener is a model that doesn't do much or too much in etcd, so it is not. I mean, we don't know. We have done it a couple of times as a proof of concept. It's not yet codified, but it worked very reliably, also under heavy outages in our own infrastructure. So we have seen it surviving these, and this was basically an additional motivating factor.
So we have a management cluster in each region for each provider, and we also use static pods for etcd and the API server.
In the management cluster and in the provision cluster.
Yes.
So the question was why we have only one, or why we have one? So
why
I understood.
3 levels in the hierarchy?
You can have n levels. That doesn't matter. So
you can actually only use you can use only one cluster, and then inside of it you can actually provision. I mean, you can have you can have your one cluster, then install the Garden control plane on it, and then you use it in order to create.
Exactly. So you also have one, and you can use it kind of as a seed and as a garden cluster all at once. We have that set up as well. So we have smaller infrastructure, smaller data centers where we basically, and isolated ones. So these ones run completely isolated from the rest, and therefore they need another gardener. They have one cluster that is manually set up right now. So with our Terraform tooling, but we don't want to have that. We want the ring everywhere. We want basically to codify that we can click a button, and then we, from a Minikube or whatever, we bootstrap that ring, and then it can run also in isolated environments. And then you can use the same cluster also as a seed cluster for all the other control planes. Of course, if you scale, then you will need eventually then more seed clusters, but they're all managed by Gardener. It's basically only configuration. You tell Gardener, okay, I want to be in these regions or whatnot, and then it creates the seed clusters as shoot clusters. And that's it. It's basically very simple deployment. The only thing so we have 2 things that we are working, or 3 things that we are working on very extensively. One is, right now it's all in source tree. So we started basically same way as Kubernetes. We knew it was basically to deliver value first. We did that, and we knew we had to change that. So right now we are doing out of tree so that we can get this, because this is now picking up. So more infrastructures. We don't want to have all the code in our code base. We need to get it out. So this is what happens currently. Then the ring. This is about to be codified. So we need specific additional components. We have written already most of them, and now we will start with the actual bootstrapping logic to codify that. And the third one is something unrelated to maybe this discussion. It's about auto-scaling of the control plane. That's a hard problem. So 1 node, 10 nodes, 100 nodes is okay. 1,000 nodes we cannot do. We need to get a lot better in that area. So that's not yet covered. So these are the main areas we are working on.
So one question I have is,
where does the persistent data live that you need to kind of persist, in case of failure?
In blob store, basically the sidecar that Martin mentioned. It's basically a sidecar of etcd, and you can pick the same infrastructure, which we usually do in configuration. So we use OpenStack Swift, or we use Azure S3, or we use, so on the different infrastructures, we use the different blob stores, and we run these full snapshots and then incremental snapshots. And should we decide to migrate a control plane, it's basically already there. You can basically go to such a, I could even show it to you, basically go to such a seed cluster, even delete the PV, doesn't matter. So etcd recovery will immediately see, wait a minute, there is no etcd anymore. Is there a backup? Yes, there's a backup. It restores it. It recovers fully automatically. So I would not even touch anything. And this is actually our standard demos. So it's the easy thing is destroy the API server. So we have nothing to do. Kubernetes covers that. That's already easy. And etcd is also nice. You just delete it, or you just break it. You corrupt it. And the guys who are doing etcd and backup, they've done such a job that basically, okay, data is corrupt, so pull the backup down and recover automatically.
So I think the question I was asking
Is there data that, you know, are the seed clusters ones that you actually have to have backup plans for, or can they be fully recreated?
It can be fully
root cluster.
So we only cover basically. So what is key? It's etcd persistence, and these seed clusters they run only control planes, and the control planes of these control planes run the same paradigm. That means they have the same sidecar. So even though we are just running a backup for the control plane, since we know in our seed clusters run only control planes of should clusters and they have already a backup, doesn't matter, we can lose everything. And basically the seed cluster gets recreated, the data is in the blob store, so it comes back, then the information is there that, what is scheduled there, the control planes of the other clusters as pods, regular Kubernetes resources, and they get then recreated. And then, of course, the etcd jumps in again and says, oh, wait a minute, where's my PV? And then it goes to its own blob store to fetch its backup. So everything can be recreated. We have never lost a single cluster.
Hi, I'm Andrew from Linode, by the way. I recently did a deep dive in the Gardener source code, and this sidecar is called etcd backup restore. And upon etcd, upon the pod, getting scheduled, you just provide it with your credentials for any block storage mechanism, and it checks to see if there's a snapshot. And it's a etcd snapshot, which I didn't know etcd itself had a snapshotting mechanism. Found that out. I was gonna, try to do something really hacky. Just checks to see if there's a snapshot, and then loads the snapshot, and it actually works really well.
Thank you.
You know what I think? It's not only about snapshot. Actually, also provides the watch mechanisms which you are using. For example, you do a complete snapshot, let's say for every hour, but then you can also store the. You would also want to have a point in time recovery where you might want to replay the certain latest data, right? So we have a watch on the etcd which streams the data continuously every 5 seconds on the post. And if at any point if everything goes wrong, then we take the latest full snapshot, but then we also play that delta of the watch that we had taken, and you lose only 5 seconds of the data.
Yeah, that was actually my question, is if in etcd backup restore, you specify an interval, if the interval is 30 minutes and someone creates a bunch of services in that 30-minute period.
Yeah, we cannot allow that. Yes, exactly. Therefore, we have added the incremental snapshotting mechanism very early on. We may not lose any data. We have only one. So we really wanted to stick to Kubernetes principles. We really wanted to avoid etcd clusters because there's so much trouble. We didn't want master election replication of data. So that was a bet. Yeah.
Does that limit you into the networking plugins that you can use on clusters? Because I know that there are some network overlays that require that the control plane, what's hosting the control plane also be part of the same SDN as the worker nodes.
It was troubling in the beginning. So we have used Calico, and we found out, it wants to basically talk to etcd, which is a no-no in our use case. But luckily, there was a configuration switch to basically talk through the API server. And that's what we are using. Yes, it limits us. Calico is fine, but we are very happy actually with the choice right now. We have also network policies, and overall, it seems quite a good balanced solution.
Well, I'm talking more generally about SDN solutions that are doing like VXLAN
between the nodes. And I know in the past I had seen if the instance hosting the control plane isn't part of that VXLAN, then certain features like execing into a pod or proxying, those things failed.
Mm-hmm. Yeah, it is a limiting factor. In the beginning, we could, for example, not span a shoot cluster, let's say a control plane on AWS and the shoot cluster on Azure, as an example. That didn't work out because of limitations in the cloud provider implementation. By now, this all works, but still we have the limitation. So we have also the problem vice versa. So API server needs to talk to the bots and services. So we have a VPN connection from the control plane to the shoot cluster. So as a sidecar to the API server, as a sidecar to Prometheus that's run in the namespace for that shoot cluster in the SIG cluster. You have this VPN connection and talks to, again, standard primitives, basically a VPN load balancer in the shoot cluster. Would there be need to, I mean, it depends. If it's only about connectivity, we can certainly find a way. We don't have one out of the box because right now it's only Calico that we support and it can talk to the API server, but you're totally right. So in the beginning, we were even more limited. Now more and more works. I mean, that was the bet. So
for the VPN, are you doing something custom within Gardener, or are you leveraging
OpenVPN?
Okay.
You basically create on the shoot side an OpenVPN endpoint and has sidecars in the asset in API server and Prometheus. Those two for Cube, extra Cube port forward, kubectl port forward, proxy. These we use that one, and Prometheus wants to scrape components in the shoot cluster. We want to have monitoring information from whatever we deploy. So we use the add-on manager to deploy stuff into the shoot cluster. Of course, we need to. Daemon sets, kubeproxy, Calico, etc. And we are collecting monitoring information via the VPN.
So to answer your question about deploying master components as non-static pods, we're actually experimenting with that, and we're deploying the API server as a load balancer service for multiple, we call them child clusters. And the one issue I've ran into is that you can't mark pods as critical that are not in the kube system namespace, at least as of 1.11. So
but you have the priority class.
Priority class.
Yeah,
okay.
you get priority classes in 1.12 or 1.11. It was GA 1.12, I think.
I've also forgotten that. Yeah.
Yeah, okay. Yeah. You have to check it, and then you can more or less specify like those components should be run with extra priority.
Great.
Yeah.
I think marking pods as critical has been deprecated at this point.
Yeah.
That's good.
We use this to reserve excess capacity in the seed clusters, that we can spin up the shoot cluster faster. If the seed cluster is out of capacity, basically, we have cluster autoscaler. It's basically the fork that you guys did based on the machine API will kick in and provision new machines. So if there are no machines available for the control planes, we like to have excess capacity, and we use low priority pods for that purpose. They get displaced immediately, then the control plane gets spun up immediately, and then a couple of minutes later, the seed cluster gets new nodes, so that for the next shoot clusters, there is capacity. So it's a nice feature of priority.
There's also, if you want to use, there's I think a feature of cluster autoscaler where you basically force it to slightly over provision.
We, I think, experimented. Yeah, I think we experimented with that. We had high hopes. Yeah, yes. I remember that one.
It was not working very well. So
there was a problem. We switched to low priority pods because that won't work really well. We were in contact, right? You were in contact with the community.
I checked with the autoscaling.
Yeah.
Because we actually created quite some time back that this is a strong use case. How do we do it with autoscaler? But it's not really easily achievable from the autoscaler point of view as well, because what autoscaler next can do is that, okay, I'll give you 3 machines extra, I can give you 4 machines extra, but that might not be the way you want to do it always. You want to somehow converge the actual workload and the machine in a way that I want 40% extra capacity and stuff like that, right? So I checked with the autoscaling folks, and they say that the nicer way seems to be is via low priority. So basically, to create the low priority pods, the pods will always let the autoscaler know that I need extra machines, and whenever the real workload will come, the real workload will just evict the low priority pods, and we will have immediate scheduling of the
And SID side priority.
So to circle back maybe to the original question about like Multimaster, are you guys sort of doing the same thing Gardener is, where you're running single master clusters?
Well, we're actually trying to do Multimaster. Yeah. We're working on, so the issue with Multimaster, I mean, it's not that much of a hurdle to overcome. We're working on it right now, is making sure that the load balancer hostname exists while the child nodes are spinning up, so that once you have the load balancer service with the API server backing it, you can have a fully provisioned cluster. I mean, yeah, we're trying Multimaster as pods.
That's what I was wondering, because when you mentioned load balancer, like one of the load balancers, if you want to. Yeah, balance across multiple things. So when you're spinning up multiple pods to make a replicated control plane for the child cluster, are you doing anything special for that, or how are you managing those pods any differently?
Not right now. This is all very experimental, but I'm just curious if there were any things you run into.
It almost seems to me like there might be kind of an inflection point,
if you are trying
to manage, just a certain number of clusters, and you're not going to have multiple clusters, per region, per provider, per availability zone,
having a
seed cluster for each of those just to manage a single cluster seems a bit overkill for that scenario. But if you are going to spin up a lot of clusters in each of those areas, it seems like, there seems to be a tipping point for, are you spending more resources on the seed cluster versus, the single cluster.
You were absolutely right. It was, again, basically we had to solve the multi-tenancy problem. We cannot solve that in Kubernetes. I mean, PVs are not namespace, CRDs are not namespace, etc. So, and we knew there are multiple lines of businesses and large corporations, and we need somehow to give them isolated clusters. So it's only a solution for mass creation or mass management of clusters. So whatever mass is in definition, but it's certainly too much for one.
Do people just run one though?
Do you people, sorry?
Do people just run one cluster? I don't know that I've ever seen a setup that just runs one.
Yeah.
I mean, you have like dev, QA, production at very minimal. I'm just asking a question. Maybe people.
Well, if you start talking about like, geo-replicated applications and everything, you're not necessarily going to run dev and QA in all of those regions and availability zones.
You have
in a limited subset.
Production clusters. I don't know.
Well, there's also there's infrastructure engineers which may be managing geographically distributed applications, but then individual developers may just want a cluster. So it depends on, I think, the perspective of the user, whether it's global or not global.
There was a very interesting talk yesterday from the cluster from multi-cluster. I don't recall what his name was, but he more or less proposed like several. So if you need from 1 to 2 clusters, if you need from 2 to 5 or 2 to 10, and then 100 and then 1,000, and so. I mean, yeah. So it was very interesting talk. So if you can spend some time looking at the video, I mean, in most of those cases, as your business grows, you're pretty much forced to expand.
And I think we have a lot of different perspectives in the room. Like as a cloud provider, we have a reason to spin up many thousands of clusters. And as a consultancy group, there would be maybe cases where you spin up 2 to 5 clusters. So maybe we have different ways to support these use cases.
So the original question was Multimaster or something else, and I think it sounds like the consensus is both.
Well, we sort of got onto a different question than that. I think the answer to that question is probably yes. I think there are many use cases like the Gartner folks have where they are not seeing a need for Multimaster, and that these tools are fine, but that can be easily extended, as Andrew is saying, to also be Multimaster if you need a checkbox for customers or something, right?
Yeah.
I think the other question we sort of stumbled upon is if we're moving towards this management cluster, child cluster, C cluster, shoe cluster model, how is the control plane for the child cluster managed, right? So there's the manage it using Kubernetes approach, and then there's the manage it using static pods approach.
And do we want to support both of those, or do we want to try and converge on a single one? And I guess, can we converge on a single one? Maybe I'll put it that way.
So my thoughts here is that our cluster CRD could just do either, and that's based on the actuator.
Well,
it would be nice if everyone didn't have to write it themselves, though.
So
ideally, we would be able to surface up something like HA
or multi-control plane versus single control plane into a common cluster API component, but then defer, somehow defer the actual control plane management to either an actuator or, some other model. Have that being,
kind of an extension
point that could implement, the Gartner model or, kind of a static
managed kind of control plane.
So, right, and I think the opportunity is there if you bake those fields into the CRD and then leave it up to the actuator on how to actually execute the control.
Yeah. So I think that's true. I think we also might gain a lot from trying to drive some consistency and say, like, there's one way that we would encourage people to do it and that we'd like to support, like, as a group. Like, if we start saying, you can do this or this, and in this case, you can do this or this, we start to have, like, 15 different models. And it's going to be really hard for us to continue to make them all work as we go forward.
I think a related question there is this operating system, is this distro agnostic? Yes. So.
Well, I think it might be hard to support all of these use cases in a way that providers have to do very, very little work. But if we thought of maybe just ways to represent, so for example, right, we have a machine set, we have a machine deployment. If in the case that you need to deploy multiple control planes, and then you could, and those multiple control planes are separate from etcd, means that they're stateless, they can be represented in the machine set. If you need to deploy etcd, and if it turns out we had 15 minutes ago we mentioned that maybe we need etcd separated out, and if we want a provider to be able to deploy that, maybe that can be represented with something like a stateful machine set. And then if we can have those primitives, there's ways to represent that, then providers, you can have I guess an AWS or an AWS provider that picks a machine set and doesn't do picks a machine set and has maybe etcd is completely external or something like that, or another provider that you can choose. I guess providers can choose representation. So then all the providers have to do is say, okay, I need these particular semantics, and then it can be written once and the bugs sort of fixed once.
So one thing that worries me is if we defer too much to the providers, we're asking a lot of the disparate providers to implement this. In one sense, it seems to me like if we are leveraging Kubernetes deployments for hosting the control plane components, that can almost be handled in a common state regardless of provider. But the other method, you're going to have, that does get deferred down into the provider in some way. And we need to be cautious that we're not asking providers, to implement too much here, because that's going to lower, or that's going to raise the barrier to entry for additional providers that we added to the community.
It sounds like from the SAP experience that's made it much easier for them to add new providers, is because the only glue
they have to add is the machine part. Like, I need to know how to create a new machine that can act as a Kubernetes node.
Well,
and like that's a much lower bar than I need to be able to create a machine that could be a node, it could be an etcd machine, it could be a control plane, it could be a part of an AJ control plane, and like having all those sort of different ways to initialize nodes is much more difficult, asking a lot more providers than create a machine, make sure Docker's on it, make sure it's got a kubelet, it'll come register.
Well, that is still a component that needs to be
able to stand up that seed cluster, though, and all of the networking and ingress requirements.
So the C cluster is a true cluster. That's not the problem, but you're right. So there's the other part. So machine API so far covers basically a very thin API of creating, deleting, listing machines. That is true. It makes it very easy to get support for that. but then there is also the networking. But I think one point not mentioned, and why we actually also did that, and why then even a few clusters are handy. In our case, it's basically providing homogeneous clusters across all these providers. So I don't know where you are going to drive cluster API to, but from our point, that is the reason why we actually started the Gardener project. We wanted homogeneous clusters. So with a shoot cluster that you create, you basically can configure, let's say, OpenID Connect, runtime configuration, feature flags of the API server, controller manager, kubelet. You can do these things. So we are not bound to SLAs in the Gardener open source project. So not speaking for my company, in the project not, and that's what we actually wanted to achieve, so that you can tweak that. And for example, if you would go with Kubernetes services out there, so one is supporting this operating system, the other one the other operating system. If they by chance support the same, maybe not in the same version. Maybe it's this Kubernetes version here. Maybe the other one has skipped this patch version. Maybe they have patched the patch version themselves. So we cannot really guarantee that the behavior will be the same. So we still can't completely, of course, networking, there are hard things that are different everywhere. But at least the components that we can control from software point of view, these we can control. And so our strategy was not so much to basically say, okay, you can plug in your Kubernetes service. Our strategy, or what we wanted to achieve, is actually on all these infrastructures to have clusters that mostly, as good as possible, feel the same, that provide the same features that you can configure, and that, be it bare metal kind of, or the big hyperscalers. So that is the key proposition that Gartner also does. Have these homogeneous clusters and manage thousands of them. So this was the goal, and that's the project about.
And for me, the question for cluster API is what's the focus? I mean, I understand this multi-cloud approach like Gartner is doing, because with Kubernetes we have quite a similar architecture, and I see exactly the same use cases, how to do this, and like also why it's easy to integrate a new cloud provider, because mostly you must implement it in your machine controller, and the only thing what you more or less need is create and delete VMs on the provider. All the rest, the heavy part, is managing the master control plane. It's done on any cloud provider from that point on, where you have a running Kubernetes cluster. But what we also see is like a lot of customers where this model is not fitting, because this model only fits like you need more than 5-10 clusters, because otherwise the overhead, the operating overhead it's much too high. And like, especially like edge cases and so on, customers want to have one cluster at the site location or two clusters. When you come in there and say, yeah, but first we must set up a first Kubernetes cluster to run to another Kubernetes cluster, they say, are you kidding?
That's why there's a toolbox for the entire SIG. I mean, it's not meant to be, using cluster API to solve all the problems is not the answer. There's a ages and stages approach. If you're doing small individual setup, use Kubernetes bootstrap. If you're doing larger multi-cluster deployments, then that's where cluster API shines. But trying to use one tool to rule all is a recipe that the SIG itself has said we will not do this. We have ages and stages and tools as part of the toolbox to solve different problems at different stages.
I think one other question that I have too is, with having the seed cluster, does that limit you to provide additional kind of network restrictions between the clusters that you're creating?
Yes. So key ranges may not conflict, these things, yeah. If you mean that.
So are you doing like subnet restriction or full VPC? Is there the ability to do like full VPC restriction between them, or?
I mean, normally your work nodes, like the pods, yeah, and the services should not overlap with your API server's pod range and then service range, and also the node range.
So you can manipulate the network settings, and the CIDR ranges must be conflict free.
Right.
Yeah.
But the individual cluster, like for the worker nodes, you know, is there a requirement that those are all within the same
VPC?
No, you can choose. Basically, either you configure to say that Gartner create the VPC for you, it creates the VPC, the subnets, that stuff. You basically only configure the CIDR ranges, or you say, I have already a VPC. I want to place many clusters into one VPC. And then since it's basically you define how the resources look like. We have also one customer who is basically creating one VPC because he needs VPC peering. So he has set that up himself, and then he's placing multiple clusters, each for his customers again, into these clusters. So he basically decides how to partition the VPC for its true clusters. I meant in the beginning, maybe you mean between seed and true cluster, because they also need to have separate CIDR ranges because the routing for the VPN tunnel.
Right.
Yeah.
Oh, so you're setting up a VPN tunnel between those. Is that also a OpenVPN tunnel?
OpenVPN, exactly. Okay. Yeah.
That's the same OpenVPN.
Yeah, this is that.
Well, no, I was asking about the root to the seed cluster previously.
No, there is no. So root is it's in general. If you have a control plane, therefore I meant with doesn't matter how many hierarchies. It's actually only one thing that is important. There's the control plane runs in one Kubernetes cluster, and the other, the nodes that are running for the which are managed by this control plane. And between those, there is a VPN from the seed cluster to the root cluster to access the pods and services. Yeah, and that's the one. Yeah, and for that,
the shoot cluster seeders can overlap, right?
The shoot clusters can overlap. Yeah, right.
But not in the same, for example.
But not in the same VPC, of course. So for that,
VPC because you cannot create.
Yeah. But you can have one seed cluster. So this is how we set it up. So the seed cluster gets one VPC range, and this VPC range is forbidden for the shoot clusters.
Actually, the only limitation is that, for example, the nodes cannot overlap. But the workers, I mean, like the pod and services, they can. Unless you have like some weird, you want to do Istio multi-cluster, and in this case, you must be 100% sure that in advance that the pod and the services IP ranges don't overlap. But only in this case they should not overlap. It's configuration again still.
So when you guys are running the control plane within the seed cluster, are there any further restrictions that you put on the usage of that cluster? For example, the end users, they cannot, for example, say go and use kube system namespace or run some other, let's say, API extensions if they have to build their own. Let's say as an application, I'm building something which is again modeled as an API extension server, and I want to run it. Well, is that going to be possible in
sure,
your model?
Yeah. Yeah.
So is there any restriction whatsoever that you guys put in?
No, but end users can really mess up everything.
Yeah, they tend to, but it is possible, yeah.
One major challenge to overcome if you're going to do this run master services as pods thing is this VPN tunnel. Otherwise, you can't use aggregated API servers. You can't use kubectl top, which is an aggregated API server. What else? Like basically the API server can't initiate TCP connections to the kubelets unless you do something special with your routing tables. So we're using WireGuard for that, and we're writing a controller to manage WireGuard for that.
Yeah, we also wanted to do this, but the only problem is, for example, on AWS, you cannot have UDP load balancers. And WireGuard is only UDP.
Yes, but you can route around that architecture.
Yeah. But we want to use Kubernetes primitives.
Right.
So, yeah. I mean, yeah, there are a lot of solutions. I mean, in the best and most happiest use case, the cloud provider can actually provide you with some APIs in which you can create like a virtual interface and that you can optionally attach to your pod, and then you have like a special CNI plugin, hopefully on for this job, but this is very specific.
So in this case, so that you can proxy probably will not work.
Exactly. Yeah, right. Also the proxy.
Yeah.
But you can do port forwards for some reason. Because port forward is based on the kubelet itself.
So in this case, you're using WireGuard instead of OpenVPN for this? Or?
Yeah, it's the same idea.
Yeah, it's the same idea.
We add some IP tables rules that say the API server can reach this net over WireGuard.
Mm-hmm. Yeah, if you have only UDP traffic, then WireGuard it's okay.
That works great if you control the environment, right?
Yeah.
The problem is you are controlling the service offering.
this is more fair.
Well, it will work. Yeah.
So what you're talking about using WireGuard is basically the same end effect that we're getting from the like you're getting the same result, which is API server will now be able to reach into the child cluster. So as far as I can tell, there are three things you have to be able to reach. You have to be able to reach node IPs directly, pod IPs directly, and service IPs directly to pass performance tests.
Yes, and the way that Gardener reaches service IPs and the way that we plan to as well is by enabling forwarding in the namespace that it terminates the VPN.
Okay, and that allows the API server to reach the DNS from the child cluster. Isn't that what it needs to resolve service IPs?
Right, it's able, yeah, because it's able to reach core DNS on its IPs. Yeah.
And that's what you're asking. So if you have those three things, then the proxy endpoint works, and you can pass performance tests. Those are like the three things you need to be able to reach: node IPs, pod IPs, and service IPs. And so it sounds like there's at least two ways people are sort of attacking that problem.
But does that mean that we're not going to add additional dependency on this OpenVPN or something?
No. It's
similar
completely
here?
depends on your implementation. So it's
Well, but
yeah.
we need some extra component. Essentially, what I'm getting at, like now we suddenly went from an independent cluster we didn't need anything special to make it work to now in this model we need at least one more missing component. Yes, there's choices what we can pick out of that, but there's still one additional component that you now deploy, manage. So an additional management overhead if an expertise needed, somebody to look at that, right? I mean, that's may be common with some, may not be common in some other companies or some other folks, right? So
yeah, there's a wide variety. So it really depends on where we want to make the cut with the cluster API. So this is actually only an implementation detail on our side, but there are different implementations with different solutions. You for sure will have your own solutions for similar problems. So everybody has them. Not sure where we want to make the cut.
The requirements are reachability of those three sets of site directives. The question is, I think you're asking is there a common way we can solve that so we don't have to all solve it separately? And maybe in the future, is there a way to solve it without having to write a bunch of extra pieces?
right, my point is like, I tend to make it like keep it simple. So essentially adding new dependencies of new components that, you know, we are kind of self-imposing on ourselves based on our design is something that we can probably take in account to see if we get to choose that or add that additional dependency only if we really are gaining a substantial amount of, you know, benefit out of it. If that's the case, then sure. And of course, it'll be nice if we can have a common way that individual providers don't have to deal with it and can handle it in a simple way, in a common way. That will be definitely beneficial.
You're trading one piece of complexity for another.
Exactly. I mean, the other thing is, you know, especially in, for example, so within VMware, like for an enterprise use case where you have already like the vCenter and all of the vSphere infrastructure component, which are also isolating your infrastructure into different silos. Well, so in that particular case, the construct of having one cluster where Kubernetes cluster, we are running the control planes of n number of Kubernetes cluster inside it. Well, it's good for manageability, I get that, but then essentially it adds additional networking complexity on the underlying infrastructure. Say either, you know, we're gonna have to.
You can now take out all of your cluster.
True.
So for me, from a failure domain perspective, it's not even a conversation. I mean, some people can do it from a management perspective, we want to back that up. But like from a failure domain perspective, it's pretty dangerous.
True.
Yeah, that's true. Gardener is also the watchdog, so this was a compromise, of course. Yeah.
I mean,
and also the other
there's
thing.
There's going to be multiple incantations and flavors of this, and I think it's going to be based upon the requirements of the provider. And like not just the provider of like cloud provider, but the provider who's actually offering the services for the different implementation details. I think enumerating the potential flavors, I don't know it's not each flavor. The different flavors of deployment configurations that one seems like a valid
way. And then we can at least scope bound those of the supported options that we recommend, right? And usually that's done in caps. Caps say like you see these different major choices. There could potentially be more, but we're going to limit the state space of incantations to these. And here are the trade-offs for A versus B. And if you choose A, then this is the consequence. I don't think you can do one size fits them all. I think that's impossible.
Sure. So do we want to go, we discussed, that kind of model. Do we want to go more into kind of the other model at this point and go back to, talking through some of the different trade-offs with, separating the control plane management from etcd, or single instance control plane that we provide, some type of resilience with through, cloud provider utilities and versus multi-control plane.
Actually, I want to dig a little bit first, if we can, before that, into like sort of the scope. I think it's that Tim was getting to is like we talk about where the trade-off is, where it becomes effective to use a cluster API. Like, we as a project, do we want to target like a full scope of managing a single cluster, deploying a single cluster, all the way up to the I want to manage a cloud provider, or do we want to like pick a smaller piece of the pie and sort of focus on one part of it? Right? I think so far we've kind of kept our scope open and said like, great, like we'll do the whole thing. Would it be more effective to focus on one part or the other?
Yeah, I think that cut is important to make. So either you want to configure all the details and configure all the knobs you want to turn, then it's a very wide API. Or you just say, okay, I want a cluster, I want to express certain things like the Kubernetes version for sure. Maybe I need to have a provider configuration for the network, this kind of stuff. But you don't have to express the rest. So basically one implementation creates the clusters as a model like with a master cluster, so C cluster in our case. Another one have these self-contained clusters. So both is possible. Do you really want to offer all these options in the cluster API? I don't know where you make the cut. This is what I meant with this question. So in the beginning I thought we are more interested to serve all of them, basically in a rather narrow API where we say, okay, we want to describe how the cluster should look like in terms of what the end user will feel. So Kubernetes version, it will be something that the user will feel, but whether or not it's a self-hosted one, because you pick solution A, cloud provider A, or the Gartner model with the seat and shoot approach is then something that is more or less expressed by picking the cloud provider. So should this be a knob that somebody can turn? If it is a knob that somebody can turn, Gartner provides only this model. GKE, AKS, all these other solutions, they have their model and they will not move, I guess. So is it really realistic that there will be any implementation where you can actually change that? That's a self-contained cluster, and I can at the same time also provide one with a control plane hosted somewhere else. I'm kind of doubtful that somebody will really implement the entire spectrum.
So ideally, we'd be building, what we should be building in cluster API should be building blocks that can then be, consumed by others. And how do we do that without, providing, if it's a, if we get too opinionated on some of these aspects, we limit, the usability by others. I think right now we're at the point where there's value seen, across, there's a lot of value seen across the board for the machines API and being able to use that. How do we go ahead and make the cluster API part of it more amenable and more usable to people?
Thin API. So with the machine API, basically we went for something that was really thin, not exposing too much. What needs to be exposed is basically configuration for the infrastructure providers. If we really want, yeah.
Well, I was just going to say, at the same time, if we got to be careful to, how do we enable it so that new providers can come in to the fold as well?
And if we are too opinionated, that will not happen. So if we define these 20, 30 knobs in the API, it will be difficult to match then a new one that wants to join, and the implementation looks completely different, doesn't squeeze in. That will become a problem.
So we look at different providers to provide these different types of control plane models, or do we, potentially variance within providers, or, what does that model look like?
So right now we have a cluster object, and there have been proposals that the cluster object should be responsible for configuring a control plane. I'm curious, what do people use the cluster resource for, if anything, right now? Because it contains the API endpoint, and we have an implicit requirement from some higher level tooling that the API endpoint, which is part of the status in cluster, denotes when the control plane is, or is at least been observed to be created once. May not be okay now, but I think that moving forward, we need to start making some of these implicit assumptions more explicit. And since that's already in the cluster resource, do we want to agree that the cluster resource or cluster controller is where this is configured?
So there's also other data that's configured in the cluster resource as well. So you have your service in your pod, network CIDRs, you have the control plane
version specified in there as well.
So
we have a subset of what we need to be able to actually configure what would be a cluster, but we currently defer a lot of that to the machine controller at this point.
So part of the reason I ask is the cluster controller has an actuator that providers can override or actually have to implement. So that plumbing is already there. That we could create a generic actuator that people could use that configure control planes for new providers if they only wanted to put the machine interface.
But that would be too generic, wouldn't it?
So I think the only thing that's missing there, I think, is a network configuration, right? So you could put a generic control plane creator in that cluster API if you went with the Gartner model, but something still has to configure the underlying network. So you still need the actuator callouts to do that.
Right, which brings us back to the machine, stateful machine.
No, I think it's more like, are you in an existing VPC? So which one? Tell us if you're in a new VPC and you want us to create it, tell us that. And on top of that, you use the machines, and then you use the Gartner technique to run the control plane off those machines, right? Versus the alternative, which is I think what we did today, which is a cluster controller. It creates a network, and then through indirection, the control plane is created by creating a machine that runs a startup script, which runs together.
I mean, one other piece of information that probably needs to go into the cluster object is like the cloud configuration for the specific provider. So today, for instance, I know for the vSphere provider, for example, we kind of piece the cloud provider information from the master machine object, which again, there could be problems with that, because if you go with, like, the moment you think about multi-masters, now you have multiple replica of that information. And let's say if you were to distribute your master machines into different, for instance, just different data stores, you might have different configurations, and you can't really extract out a common.
Your master shitty machines, like by definition, for what we talk about, even with the SIG recommendations, master shitty.
No, they're homogeneous. So what I'm saying is, like, for example, just from the placement perspective, for example, on the vSphere infrastructure, which data store? So you don't want to have all the 3 masters VMs landing on the same data store just to get the storage, it's just to protect your masters from one single storage going down. So that's the only, I mean, they're homogeneous from all other aspects. I mean, right. I mean, so one option, at least, of vSphere, for example, if we could use like storage cluster, today we don't use storage clusters at the moment in our vSphere provider implementation. We are directly going to a selection of a data store, but that's something that we can essentially definitely improve with that implementation. But I'm saying, with the current set where someone may or may not use a data store cluster, therefore they may have to go and say select a particular data store of their choice for a master node, for example. And in case of a multi-master, you might want to select just different data store just for that reason, since the underlying infrastructure, you're not relying on that to do the very same thing. So the point is, the way today the cloud configuration for the vSphere cloud provider is extracted, it's kind of extracted literally from the master node spec, which I think is better suited if we actually put it in the cluster object from the, because then it's like one cluster wide configuration that you're doing and not essentially a specific type to, one master.
So there is a place in the cluster object where you can put the provider spec for the cluster. So you can actually just double that up into the provider spec for the cluster or the vSphere provider.
Yeah, that's actually what we plan to do, but essentially just to the point, what kind of information basically gets into the cluster is, this is and yet another piece of information that will probably need to be in the cluster object across the board if the cluster object were to be used to actually lay out your control plane, because then regardless of the provider, that control plane will need to be configured with the appropriate cloud provider configuration for, whether it is AWS, HKE, vSphere, doesn't matter, right? So that piece of information necessarily will now need to be part of that object, like in a mandatory form.
Right. I'm wondering if you do the Gartner approach, Tim mentioned affinity, anti-affinity, if you created machines that map to different data stores and labeled those, you could literally use a Kubernetes scheduler to make sure that the entity was spread across data stores.
Right. I mean, I'm actually more talking about right now the current model, what we have, which is you don't use static pods and you have just different machines. Not exactly the Gartner model. But
right. No, I'm just saying, because otherwise you're going to start re-implementing some of those Kubernetes yourself. So instead of letting Kubernetes do it for you, you're going to start encoding some of that same logic. I think that's where SAP found, we don't want to rebuild that logic, let's just use it because it already exists.
Right. I mean, we kind of doing that for our worker nodes, for example, for our use case. I mean, that's precisely what we're doing as well. I mean, when we create our worker nodes, we spread out, label them properly, and let Kubernetes handle, from the workload perspective, the availability aspect of the stateful services for that matter. But I'm just saying, since this is not the worker, now it's like your control plane becomes the workload in this Gartner model. And since we are not there yet in cluster API, therefore, we have some differences there at the moment.
One thing I'm worrying about right now is if we do go ahead and just keep deferring this to the provider implementation, are we basically forcing providers to, replicate the same logic?
I don't actually think that that's a bad thing until we get past alpha. I actually think that's probably a good thing because each individual provider is going to come up with some incantation that makes sense for them. And then usually you distill down the requirements after you've gone through the hellscape for each individual provider. So I think until we reach, I think we should absolutely distill it before we reach the beta. That makes a ton of sense. But for an alpha, I don't see this as a requirement that force us to try and find commonality before we actually cross all these different solutions.
Because part of the notion of the provider only has to implement the machine actuator, that the cluster actuator provisions the control plane components.
And the boilerplate in most cases, around the infrastructure boilerplate,
So right now, you interact with the cluster API and you say, give me a cluster, but you don't actually get a cluster. You just, depending on the cloud provider, you either get nothing or you may get, in the AWS provider, you'll get a VPC subnet, load balancer, those sorts of things. It's not until you actually somehow initiate the control plane, whether it's stand up a machine or somehow deploy control plane components, that the cluster actually exists. And that almost seems, it's non-intuitive to an end user.
Yeah, and that was my point, which is, do we want to give the cluster, do we want to associate credentials with the cluster object that are capable of performing the provisioning step, and then how distro agnostic is that?
Well, in the case of the AWS provider, you're already providing a wide set of permissions in order to create the networking objects and things like that. So, yeah. And truthfully, the controllers are generally running within the same controller manager and have access to the same secrets and that sort of thing anyway. I mean, currently.
That's an open question.
I mean, like the way we're looking at it right now for the AWS provider is currently we've been telling, people who want to demo the AWS provider, go ahead and run cluster cuddle, you get a cluster and, you go ahead and play around with it. As we start to look at how do we implement, multi-control playing, we can no longer use the cluster cuddle workflow. So we're looking at potentially, first documenting, using the phases in cluster cuddle, how do you stand up, a control plane, a multi-control plane cluster using cluster API. It works, we can do it, but there's some kind of machinery there that's going to have to be repeated by everybody, in order to take advantage of that. Or we hard code a particular way to do it in cluster cuddle, but that still seems, it just feels wrong.
I agree with Tim and Jason. Tim, that we don't perhaps have to decide this now, and Jason, with that we really don't want to force everyone to do this themselves. And it occurred to me that maybe SIG ADM will make it so easy that everyone can do it themselves.
I think it defers the problem. I mean, it makes the control plane and the controller manager and API server a bit easier, but you still have the same problem when you talk about how do you stand up etcd.
What do you mean?
Well, do you have just one etcd instance, or do you have multiple instances? Is it part of, the control? Does the cluster controller handle it, or does, is that handled externally like we're doing today?
Right. I think SIG ADM doesn't handle the managed control plane case. But I think whether you have one or in members of the control plane, that's go.
Just like with KubeADM, though, you have to somehow say somebody's going to run init, and other people are going to run join. So you can't just spin up 3 things that are labeled as masters to run exactly the same script and expect them to magically turn into a multi-master control plane.
Sure. Kind of can if you use CoreOS's broker service, I forget what it's called.
Or if you use what Cops does for their master lecturing thing, just some clouds.
Well, now you're adding a new requirement of the broker service, or potentially you can use DNS records, but then that's also introducing DNS's requirement as well.
So I think there are ways to say, like, I have one startup script for masters, and it'll figure out if it should init or if it should join something that already exists. So we could probably figure out a way to solve that problem. And then, especially with etcd admin, maybe that would get us to what you're looking for, right? Where you can say,
well, I mean,
cluster cuddle create, and my list of machines has 3 machines labeled master, and they just turn themselves into a multi-master.
I mean, the way that we're looking at right now is basically, we've basically taken the role and moved it down into the provider config. We have the control plane role, and now we're looking at, as we add the HA, just basically adding a additional control plane or some name for the role that indicates that it should join, but it works, but it'll work, but it's not ideal.
So Cops creates a distributed mock with some disk.
Yes.
Okay, that's interesting.
You can adjust it if you want to do it. So we have like 20 minutes left on your original invite. I'm not sure it actually addressed the question you brought up at the beginning and caused us to make this get together. I think it has actually been really useful for other reasons. But I want to make sure that you get something out of this that you were hoping for, so it's help organize. So do you want us to kind of focus maybe the last 20 minutes on trying to give an answer to the initial question that prompted us to create this?
No, I think we've covered a lot of ground. I think there's a lot more shared context now than there was previously. Hopefully we've recorded that shared context in a manner that people that haven't been able to attend can, go back and see it. I do think it makes sense at this point to defer, and I would love to see a more formal proposal, how we could kind of potentially adopt the Gartner model, and we can potentially work through kind of some other approaches as well. But as far as adding HA in a more managed scenario, it probably is a good idea to go ahead and continue proving it out before we try to
build something and then we'll see what needs to be fixed.
I think just enumerating the options is good. Coming back before now to revisiting or it's required for long session now, like this phone conversation. Here the notes before we cut data.
One question that I do have, before we wrap up, did people actually find this valuable? I mean, I know I did, but
pretty much, yeah.
We don't have to, no, I actually wanted to dig back into the Gardner question that David asked earlier, which I'm not sure I fully understood, which was like how small of a scale can you run it on, right? Because I think people have been asking, it sounds great if we want to create lots of clusters, but if we want to create 5 or less, like Sebastian was saying, like, and I thought you mentioned you would kind of collapse it all onto a single cluster. Like, what does that look like? Or is there a minimum of 2? Or like, what's the smallest footprint that you guys have tried or that you could do?
Basically, the ways that you have is Gardener API server, Gardener controller manager, and then this additional control plane for a seed cluster, which will be pretty minimal. So this is the way. So in more concrete words, you would have one cluster, there Gardener is deployed, and it would host the control plane of another cluster. It would be that is your target cluster. So this is actually not even waste. So depends on are you having this ring or not, but let's assume you have already this root cluster and you want to spin up only one single cluster, right? Then the control plane of that cluster needs to be placed in this first cluster. So this one is no waste, but you of course have this first cluster where you need to have Gardener running. So this is basically your fixed cost. So you need to pay for that. If you have just one cluster, you basically have as a fixed cost one additional cluster, this root cluster kind of thingy that we call Garden cluster where Gardener runs. That's your waste. If you have 5 clusters, it's this one cluster divided by 5. If you have 100 clusters, you might have maybe 2 seed clusters, something like that. Then it's these 100 divided by these 2. So it really depends on how you scale out. So our largest seed clusters run, I don't know, 150, 200 clusters. They could run more, but we basically said no, we cannot scale out to 1,000 nodes. So this we have not yet simply implemented. It's not there. So we basically scale to 100 nodes, and then we say we open a new seed cluster. That's basically how it works. So you have this waste kind of one control plane that you need to host for the seed cluster. The seed cluster, or every shoot cluster for that matter, it basically contains only the machines. So there is no waste there. You put stuff there. Of course, you have fragmentation. I mean, the machines are not fully utilized until you fully utilize them. So if you have a large node and you place only one control plane onto that, of course, then the waste is larger because you have less utilized resources. But our driving factor was also, since we also came from Bosch Cloud Foundry, was to increase the utilization. So there was a lot of waste in basically using virtual machines only. Of course, you can tweak that underneath with overcommitment, whatnot, but we wanted to stick with Kubernetes. And we said, we are deploying these pods. I mean, there are means in Kubernetes to basically scale automatically out, up, in, down, and that we wanted to utilize. So if it's just a small seed cluster, it will be a very small control plane as well, because it has to manage only one other control plane. There is not much waste in it. But it is, of course, much more. So it is, of course, waste if you want to have just one cluster. The pro side, which was our motivating factor, is providing the homogeneous clusters. And another pro side of that model, and what we are doing with extensibility, so I'm not quite sure if you have talked about that already with the cluster API, we are also doing extensibility not only to make infrastructure support pluggable, but also to make various other things pluggable, like the operating system. Like in some cases, I mean, you're all working for large corporations maybe, and you have your own audit logging solutions. We have it as well. So we cannot plug in any solution. Audit logging is something that needs to be handled very specially. So you need to configure the control plane to this needs to be extensible. So right now it's basically some add-on that we deploy from the side, and it watches the seeds, watches the shoots, and then it basically has a mutating webhook to get this stuff in. Of course, we want Gardener to manage it, not knowing that it's managing it. So basically also the shoot spec will become something that can be extended. So if you if you want to configure metering, audit logging, these other things that are not core business of Gartner. Gartner's core business is the control plane. If you want to have these things, but want Gartner to transport it into the SIG cluster, should clusters, there should be a means to do that. So this is also part of the extensibility. We don't want too many additional components. We want to basically facilitate that, but not know that we are actually injecting these components. Gartner should not be aware, because then this makes API complicated. So today we have this API, tomorrow it needs to be too complicated. We want the flexibility kind of for the owner of this infrastructure to decide how to enrich the clusters that are provisioned. So not sure whether you want to touch it at all, or like we did in the beginning, basically say that's not our business. Somebody else has to watch what's going on there and inject these things from the side. As said, we don't want to put that into the contract, but we want Gartner to basically facilitate that, and we want the cluster resource that we are having needs to be put in there. So you can describe, oh, I want the audit logging in this way to be configured. I want this audit log policy, whatnot, or I want this metering solution, that this can be configured. Gartner doesn't care, but it basically deploys into the C cluster some controller manager. And so the idea basically is it takes these snippets, it puts them into the C cluster. It has an anonymous list kind of controller managers that it's also deploying there. Yeah.
There's many ways to do this. I see how it simplifies some problems there, but I think we need to disambiguate what is provisioning from what is policy.
Okay. Fair enough.
Because that's, you can do policy.
Yeah.
I think that's kind of the key for how we try to do layered approaches for, this is where this tool stops and this is where this tool begins.
Yeah.
There are many ways to enforce policy that doesn't really have to have a C cluster that does the control enforcement policy that way.
I think in some ways Gartner's kind of like hops, where it's the whole box. Right? Yeah. We're trying to figure out like other pieces of it that we want to extract.
No, I get it. I'm just trying to make sure that we don't.
If you go to the original question, I saw like one survey, and in which 78% of the people which are using Kubernetes at all are having between 1 and 10 nodes or something like this. And even yeah. I mean, almost the 8% of everyone is using like very small clusters, and for them, the control plane will be, from what I've seen, 1 or 1.5 gigabytes at all, just running as memory. Yeah, in most cases. So
even if they're
it's completely pointless.
So it is true. Most of the clusters that people create in the infrastructure from development teams are small. Then again, if you have a large corporation and you're creating 1,000 of them, it pays off. So not every cluster needs to have 3 virtual machines. That's the kind of waste that you don't want to have.
Especially for cloud.
Sorry?
Yeah, especially for clouds.
Yeah, definitely. Yeah.
I think that's my question. Justin Santa Barbara and I were chatting the other day about ways that we could use Minikube as like a ephemeral version of your the garden sort of cluster, like the management one. Even if it wasn't around for like part of the time, there are ways to kind of make that sort of work. I don't know if we're going to get some ideas. Hopefully we can come back with that, because I think one of the sort of objections is, if I want 1 cluster, I need 2, right? And is there a way we can say, if you want 1 cluster, we can just give you 1. If you want 3 clusters, we'll give you 4, and those 3 will be much more reliable.
So in that case, would that instance only be temporarily available and wouldn't
be reconciling over time, or?
Yeah. And you could do something like
snapshot that at CD, so you could like sort of recreate a new Minikube or sort of a new ephemeral management cluster if you wanted to change things. But in a lot of ways, it wouldn't be that different from what we end up deploying today when we pivot, because once you pivot, the controllers running on that machine are just they're static pods. As long as the kubelet tree knows file, it'll keep running them, which is kind of similar. Just schedule something on the machine and then to avoid the control plane.
Yeah, I just worry with that approach, like that data has to persist somewhere to be able to get it later, and the requirement that that's adding beyond the requirement that you have with the cluster.
So that's not perfect, but it might be more desirable than
having to run two clusters.
I mean, currently you cannot do this thing because your API server needs to be able to talk to your. I mean, it's able to talk to its bot, but the kubelets and all those components need to talk to your API server. So you cannot currently host it on your own machine theoretically. You cannot, but I mean, what I'm currently doing is for development. I spin up Minikube. I launch the control plane for our gathering thing, and then I simply connect to one of our existing clusters, and then I simply use it as a seed cluster, and that's it. So it's trade-off. So there's always a trade-off. So you cannot just have. I mean, you cannot create clusters from AWS just on your own work machine that will run on your here. Yeah.
It seems to me that yes, Minikube approach, we also do the same thing for local developments. We use Minikube, host Gardener there, and then connect with the existing seed cluster. But what could be also possible and seems reasonable is that you can always combine the Gardener and the seed cluster inside the one cluster itself. And that's also a setup we have been doing for small infrastructures, where we have a small number of shoot clusters, right? And that should also work out, just one cluster. And to add on that, you don't necessarily need to pay a lot for that one cluster, but you by default get the cluster autoscaler as well for those clusters. So you can have a bare minimum number of machines in it, and as and when more control planes are required, that cluster will automatically scale itself.
Yeah, and there's clearly the conceptual overhead of having two clusters instead of one. But the actual resource footprint may not be significantly different because the management cluster, if that includes the control plane for the other cluster, then you're basically splitting the roles and saying, well, before we had management, or we had control plane nodes and worker nodes. Now we have the control plane nodes are effectively the parent management cluster, and the worker nodes are still worker nodes. Maybe you actually use the same resource footprint.
Exactly. So if you span up the ring, you can even have only one worker node per cluster. If it is large enough to host the control plane of the next one, this makes 3 VMs, which effectively is the same thing as if you would have 3 dedicated masters. Yeah, that was the thinking behind that as well.
But you do have like 8 gigs of overhead per seed cluster. If you try to run a high availability seed cluster.
Yeah. I mean, yeah, HA. I mean, there is also overhead, so nothing is free. So.
Should we call it until the recording?
Yeah.
Thank you everyone who was remote. Hopefully this was somewhat useful for you. It was useful for people over here. Hope to see you in person.